Here we will be continuing with the exercise 10.3. Actually these problems are simple. You can solve by yourself. What you do is just take down the question. Okay, solve by yourself. Finally you verify your answer. That's enough because simple problems are there in this exercise. Okay, let us start with this. Find magnitude of A vector and magnitude of B vector. If it is given A vector plus B vector dot A vector minus B vector is equal to 8, and dot product of these two vectors are given, and magnitude of A vector is 8 times the magnitude of B vector. First we will take this given condition, okay, that is A vector plus B vector dot A vector minus B vector is equal to 8. See, while multiplying this dot is very important, okay, you have to write like this: A vector dot A vector minus A vector dot B vector, right? A vector dot A vector dot B vector, that will be minus, plus B vector dot A vector, then minus B vector dot B vector. Yes. Now A vector dot A vector will be magnitude of A vector square. Now here see this, A vector dot B vector and B vector dot A vector will get cancelled because it is commuted to the wholes. Now minus magnitude of B vector dot B vector will be magnitude of B vector square, and sorry, here I forgot to write, is equal to 8 is given. So this we got magnitude of A vector square minus magnitude of B vector square is equal to 8. One more condition is given, magnitude of A vector is equal to 8 times the magnitude of B vector, right? We'll substitute this. So this is now magnitude of A vector will substitute as 8 magnitude of B vector whole square, right? Minus magnitude of B vector square is equal to 8. Now 8 square will be 64. Magnitude of B vector square minus magnitude of B vector square is equal to 8. By this we can write 64 minus 1 will be 63. Magnitude of B vector square is equal to 8. Right? Magnitude of B vector square is equal to 8 divided by 63, or magnitude of B vector is equal to square root of 8 by square root of 63. So this can be written as 4 into 2. So this will be now 2 root 2 divided by, this can be written as 9 into 7. So it will be 3 root 7. So this is the magnitude of B vector, right? Now we need to find magnitude of A vector. What you have to do? Here condition is there, right? We got the magnitude of B vector. So what will be the magnitude of A vector? So magnitude of A vector is equal to 8 times magnitude of B vector. It is 2 root 2 divided by 3 root 7. So you can multiply 8 into 2 will be 16 root 2 divided by 3 root 7. So this is the answer. This is the magnitude of B vector and this is the magnitude of A vector. Okay. Simple. See, final answer. This is the A vector and this is the magnitude of B vector. Now we'll move to the next one. See, simple it is. Evaluate two vectors, given and scalar product you need to find. Just multiply 3A vector, see there, 3A vector dot 2A vector, then plus 3A vector dot 7B vector, right? Minus multiply 5B vector dot 2A vector, then minus 5B vector into 7B dot 7B vector. Now 3 into 2, that will be 6, right? Magnitude A vector dot A vector will be magnitude of A vector square, and this is here, see, 3 into 2 will be 21. A vector dot B vector, this is minus 5 into 2 will be 10. B vector dot A vector minus 5 into 7 into 5 or 5 into 7, 35 magnitude of B vector square. Now final answer will be here. This one can be the 6 magnitude of A vector square. So this is 21 minus 10 will be plus 11 A vector dot B vector, right? So this can be written as A vector dot B vector. This is the remaining minus 35 magnitude of B vector square. So this is the answer. Find the magnitude of two vectors A vector and B vector. We need to find the magnitude of, magnitude of A vector and magnitude of B vector. Okay. This type of problems are important for 2 marks. Remember, having the same magnitude, both the magnitude of both the vectors are same. So I can write magnitude of A vector is equal to magnitude of B vector. This is given. Next, what is given? Such that the angle between them is 60 degree. Angle between the A vector and B vector is 60. That is theta is equal to 60 degree is given. And one more thing, the scalar product is 1 by 2. Scalar product of A vector and B vector, or dot product of that is 1 by 2. That will be that scalar vector, or we can say that scalar product or dot product. So this is A vector dot B vector is equal to 1 by 2 is given. Since angle is given, dot product is given, we need to find the magnitude. We can go with the A vector dot B vector formula, right? A vector dot B vector is equal to magnitude of A vector, magnitude of B vector into cos theta, right? So here A vector dot B vector, what is the value? It is given as 1 by 2. Let me substitute this. 1 by 2 is equal to magnitude of A vector. Since magnitude of A vector and B vector both are same, magnitude of B vector can be written as magnitude of A vector, right, into cos theta. Theta is now 60 degree, right? By using this, see, 1 by 2 is equal to magnitude of A vector into magnitude of A vector. It will be magnitude of A vector square into cos 60. Cos 60 is 1 by 2. So that I can cancel 1 by 2 and 1 by 2, right? So by this we can write magnitude of A vector square is equal to 1. Now what is the magnitude of A vector? Is it plus or minus 1? Minus 1 is not possible, right? Because it's a length. So it will be plus 1. Magnitude of A vector is 1. That is equal to the magnitude of B vector. So this is equal to magnitude of B vector. So final answer is magnitude of A vector and B vector both is equal to 1. This one important for 2 marks. Okay. Find magnitude of x vector if for a unit vector A vector. If for a unit vector A vector, see, this is nothing but the unit vector is nothing but magnitude of A vector will be equal to 1. Now here we need to find the dot product. X vector dot x vector. So don't skip any step. Okay. X vector dot x vector plus x vector dot A vector minus A vector dot x vector minus A vector dot A vector, right? So this is equal to 12. Now I can write this as magnitude of x vector square, and this will get cancelled. It is minus magnitude of A vector square is equal to 12. Now magnitude of A vector is, it's a unit vector, so that magnitude will be equal to 1. So I can write magnitude of x vector square minus 1 is equal to 12. So magnitude of x vector square is equal to 12 plus 1 will be 13. So magnitude of x vector is equal to root of 13, not plus or minus, only root 13. Remember this, don't write plus or minus, it is always positive, it is root 13. So this is about the first one. See, this is important for 3 marks, important problem. If A vector is given, B vector is given and C vector is given are such that it is given that, see here, A vector plus lambda B vector is perpendicular to C vector, then find lambda. Try to understand the question. What is given? See, A vector plus lambda B vector, this is perpendicular to C vector, and by using this one you have to find the value of lambda. So if they are perpendicular, then their angle between them will be 90 degree, right? So dot product of these two will be equal to 0, right? So what we can write, A vector plus lambda B vector dot C vector will be equal to 0, right? By using this we can find the value of lambda. For that first we need to find the value of A vector plus lambda B vector. Is it clear? First let us find that. A vector plus lambda B vector. A vector plus lambda B vector. Better you write each and everything, okay? 2i cap plus 3j cap plus 3k cap plus lambda into B vector is minus I cap plus 2j cap plus k cap. add this. So this will be now 2, right? Plus lambda into minus 1. So what I can write? 2 minus lambda I cap, right? Plus this will be 3 plus 2 lambda. This whole vector is multiplied with lambda. So this will be now minus lambda I cap, 2 lambda j cap. This will be 3 lambda k cap, right? Directly we can write this 3. This will be plus 2 lambda j cap, and last one plus 3 plus lambda k cap. So we got a vector plus lambda b vector. Now we will find the dot product of that. It will be see a vector plus lambda b vector dot product with c vector is equal to 0. Since it is given, right? These two vectors are perpendicular. Now we will substitute that value. See, this is now 2 minus lambda I cap plus 3 plus 2 lambda j cap plus 3 plus lambda k cap dot product with c vector. What is c vector? It is given as 3 I cap plus j cap. So let me write here 3 I cap plus j cap. This should be equal to 0. Now dot product is nothing but you have to multiply the corresponding elements and you have to add it, right? So this will be equal to now 2 minus lambda, coefficient of I cap 2 minus lambda multiplied with here 3, right? 2 minus lambda is multiplied with 3 plus next will be j, here j. So this is 1 is there, so it will be 3 plus, I hope you are getting this, 2 lambda into j, coefficient is 1 plus there 3 plus lambda k, right? So lambda into coefficient of k will be 1, right? Here nothing is there. 3 I cap plus j cap. I can write plus 0 k cap. So you have to multiply that with 0. So this is equal to 0. I will simplify this. So 3 into 2 will be 6 minus 3 lambda plus 3 plus 2 lambda is equal to 0. So here 6 plus 3 will be 9. Minus 3 lambda plus 2 lambda will be minus 9 lambda is equal to 0. So the value of lambda is equal to 9. Now show that two vectors are given. This vector is perpendicular to this vector. You have to prove these two are perpendicular each other. That means you have to show the dot product of those two is equal to 0. Simple it is. So here I write magnitude of a vector, b vector first plus magnitude of b vector, a vector. I will consider the dot product of those two, that is magnitude of a vector, second vector, b vector minus magnitude of b vector, a vector. I will multiply this. So this is C. Directly I write here magnitude of a vector into magnitude of a vector will be magnitude of a vector square. Next b vector dot b vector, right? Remaining with b vector dot b vector plus, now if you multiply this, so this will be now C minus magnitude of a vector, magnitude of b vector into a vector dot b vector, right? We multiply with this one plus, so this is now magnitude of b vector, magnitude of a vector, that is a vector dot b vector. Last term is minus magnitude of b vector into magnitude of b vector, which will be magnitude of b vector square and a vector dot a vector. Clear? See here, I can cancel these two. Now again, see this magnitude of a vector square, b vector dot b vector will be magnitude of b vector square, right? And here magnitude of b vector square is there, a vector dot b vector, a vector will be magnitude of a vector square. So both are same. You can cancel these two also. Write it properly, okay? So this is equal to 0. So those two vectors are perpendicular each other. See this? If a vector dot a vector is equal to 0 and a vector dot b vector is equal to 0, then what we conclude about the vector b? Can you say? Simple it is. See, a vector dot a vector is equal to 0 is given. That means magnitude of a vector square is equal to 0. I can write magnitude of a vector is equal to 0, right? Since magnitude of a vector is equal to 0, so obviously a vector dot b vector will be equal to 0. So what we can conclude, b vector may be any vector. Since magnitude of a vector is equal to 0, we can say that b vector may be any vector. You can consider any vector, but the dot product of that will be equal to 0. It need not be 0, okay? Any vector it may be. So, but the magnitude of a vector will be equal to 0. See this? If either a vector is equal to 0 or b vector is equal to 0, then dot product of those, that is a vector dot b vector will be equal to 0. That is, now converse need not be true. What will be the converse of that statement? We have to assume that a vector dot b vector is equal to 0. Right? We have to find a vector dot b vector is equal to 0, and we have to prove that a vector is not equal to 0 and b vector is also not equal to 0. That means magnitude of a vector is also not equal to 0 and magnitude of b vector is not equal to 0. Is it clear? See, it is given that a vector is equal to 0 or b vector is equal to 0. Then obviously this will be true. But the converse of that is not true. So you have to justify your answer. For that you have to take one example and you have to prove that a vector dot b vector is equal to 0. But a vector is not a 0 vector and b vector is also not a 0 vector. Okay. It is equal to 2 I cap plus j cap plus k cap. This is a. Now I will consider b vector is equal to, we will consider 3 I cap plus 2 j cap. Now see here, 2 into 3 will be 6 plus 2 into 1 will be 2. So this 6 plus 2 will be 8. So I have to get minus 8. So I will consider this as minus 8 k. Is it clear? Any example you can take. Here if you find the dot product of this, a vector dot b vector is equal to multiply 2 into 3 will be 6 plus 1 into 2 will be 2 minus 8 into 1 will be minus 8. 6 plus 2 is 8, minus 8 will be equal to 0. So, a vector dot b vector is equal to 0. Now, what will be the magnitude of a vector? See here, root of 2 square is 4 plus 1 plus 1. So, it will be 6, root 6. And magnitude of b vector is equal to root of 3 square is 9 plus 4 plus 8 square is 64. 64 plus 4, 68. 68 plus 9 will be 77. Right? So this is the answer. So magnitude of a vector is not equal to 0. By this we can say that a vector not equal to 0 and b vector is also not equal to 0. Any example you can give here? See this one. If a vector, b vector, c vector are unit vectors, so that means I can write magnitude of a vector is equal to magnitude of b vector, that equal to magnitude of c vector is equal to 1. So that is given. Now, such that a vector plus b vector plus c vector is equal to 0 vector. By using this, you have to find the value of a vector dot b vector plus b vector dot c vector plus c vector dot a vector. First, we will consider the given condition. It is given a vector plus b vector plus c vector is equal to 0 vector. Now, we will take the square. So, it will be a vector plus b vector plus c vector whole square is equal to 0 vector, right? Squaring the 0 vector. Now, you can see this is of the form a plus b plus c whole square. What will be the formula? A square plus b square plus c square plus 2ab plus 2bc plus 2ca, right? We will use that formula. So, here it will be a vector square plus b vector square, right? B vector square plus c vector square. So, c vector square is nothing but you can write this as a vector dot a vector, right? A vector dot a vector is nothing but magnitude of a vector square. Plus 2 into a vector dot b vector plus b vector dot c vector plus c vector dot a vector. So, this is a vector square is nothing but magnitude of, I can write a vector dot a vector, right? So, this is now magnitude of a vector square. Clear? Directly I will substitute here. So this is now magnitude of a vector square and this is magnitude of b vector square and this is magnitude of c vector square plus 2 into a vector dot b vector plus b vector dot c vector plus c vector dot a vector. This is equal to 0. This is given. Now this will be 1, right? Magnitude of a vector is 1. B vector is 1. C vector is also 1. 1 plus 1 plus 1. It will be 3. So I can write here 2 A vector dot B vector plus B vector dot C vector plus C vector dot A vector is equal to minus 3. Right? This is 1 plus 1 plus 1, 3. So when it goes there, it will be minus 3. So value of this is equal to, A vector dot B vector plus B vector dot C vector plus C vector dot A vector is equal to minus 3 by 2. You got the value of this one as right. A vector dot B vector plus BC plus C. So this should be the final answer. If the vertices of a triangle ABC is given are A is 1 to 3, B is minus 1 0 0 and C is 0 1 2 respectively, find angle ABC. You need to find the angle ABC and this angle is between the vector BA and BC. So if I consider this as AB and this is BC, so angle between B to A vector and B to C vector, we need to find this angle. Is it clear? Now see here, to find the angle we have the formula cos theta is equal to A vector dot B vector, but in the place of A vector and B vector we have BA vector and BC vector, right? We'll substitute this BA vector dot BC vector divided by magnitude of BA vector into magnitude of BC vector. For this find BA vector. See here, BA vector is nothing but B to A. You have to start from here. 1 minus of minus 1 I cap plus 2 minus 0 j cap plus 3 minus 0 k cap. First you write that, then only you write the vector. Okay. Here I write directly, but in exam, first you need to write the step. After that only you write. Okay. So see this 1 minus of minus 1 will be plus 1. That is 2 I cap 2 minus 0. It will be 2 j cap, right? 3 minus 0 will be plus 3 k cap. So this is a BA vector. Now I have to find BC vector. See this B to C. So I have to start from here. This will be 0 minus of minus 1 will be plus 1. So this will be now I cap 1 minus 0. So it will be plus j cap and this is 2 minus 0. It will be plus 2k cap. Right? We will find the magnitude of BA vector is equal to, that is square root of 2 square 4, 2 square is 4 plus 3 square is 9. So 9 plus 4 13, 13 plus 4 will be root 17. Now this is magnitude of BC vector is equal to 1 plus 1 plus 4. It will be root 6. Right? Now just to substitute here. So cos theta is equal to BA vector dot BC vector. So we need to find the dot product of this, right? First we'll find that BA vector dot BC vector is equal to, see 2 into 1 will be 2 plus 2 into 1 2 plus 3 into 2 will be 6. So this is equal to 10. Dot is there. Okay. So this is equal to 10. Now we'll substitute this. Cos theta is equal to BA vector dot BC vector is 10 divided by root 17 into root 6. So I can write this as 10 by root 17 into 6 will be 1 or 2, right? So this is the value of cos theta, but we need theta. So theta will be equal to cos inverse of 10 by root 1 or. This completes the exercise 10.3. Few more problems are there. You solve those. Okay. And next we are moving to the vector cross product.